Hello friends, as we have already discussed regarding serial communication of PIC microcontroller, some basics like types of serial communication and subtypes of serial like synchronous and asynchronous serial communication. Along with that, we have discussed regarding the USART, that is universal synchronous and asynchronous serial communication, in that the two registers which are used for accessing or developing the communication between transmitter and receiver. So after that we discuss regarding one register which is used to select the baud rate for asynchronous type of serial communication mostly. So the baud rate generator, that is baud rate generator register, BRG register, is used to decide the baud rate, and the value of baud rate which is to be selected is stored in SPBRG register. SPBRG is a 8-bit register and BRGH is a single bit in which we have to make the low baud rate or high baud rate. So based on the dividing factor, the crystal oscillator, and here we decide whether it is divided by 16 or whether it is divided by 64. If it is divided by 16, as we shown in this table, so if it is divided by 16, then baud rate is high or more as compared to the baud rate when it is f oscillator divided by 64. X is nothing but your baud rate value which is to be stored. The next part is the PIC microcontroller supports USART, SPI and I2C communication protocols. In this case, USART, it will be useful for mostly asynchronous type of serial communication, and in that generally we discuss regarding the transmitter side and receiver side. So and after that we discuss about the SPI and I2C communication protocols. So in case of USART, we see the two separate block diagrams, that is working structures of transmitter side as well as receiver side. So let's move towards the USART transmitter. Here in this diagram it is mentioned that a transmitter pin at RC6, that is TX, is useful for the transmission of data. But before that, the internal structure is like that. Here we have to select the baud rate, and the count for baud rate or value for baud rate is mentioned in SPBRG register along with the TXEN, that is enable the serial communication is required. So TX transmission enable is done here, and TX REG register, which is actually connected to the data bus or CPU side, which contains the actual contents, data contents, and this register TXREG register is connected to the TSR register, and TSR register is nothing but it will generates and data frame which is to be transmitted along with start bit and stop bit adding. So here uh, TSR register is helpful for transmission of data from TSR to the buffer register. So in buffer register it will wait for the complete transmission of the data. For the TSR register, one more bit is there, that is for the transmission of 9th bit data by the logic circuit of TX9D and TX9. Here TX9 is nothing but we are enabling the 9-bit data transmission by making TX9 is equal to 1, and whatever the actual contents are there which are applied to the and gets second input, that is TX9D. So if it is TX9D is equal to 1, then automatically AND gate generates output 1, as TX9 is always 1 for 9th bit of data transmission. If 9th bit is 0, then output of that 9 gate becomes 0, that is low, and 9th bit is low. So based on that, here 9th bit is transmitted with the help of TX9 and TX9D towards the TSR register, and whenever the contents are transmitted from TXREG register to TSR register, here mention that 8-bit data is transmitted from TXREG towards the TSR register, and after that transmission it will generate the interrupt, that is TXIF interrupt, as contents are transmitted from TXREG towards the TSR register. And when TSR register becomes empty, that is contents of TSR register, either 8-bit or 9-bit, are transmitted completely towards the buffer register, that is buffer and control section. In that case, after that, if TSR is empty, in that case TRMT bit becomes high, that is set to 1. So when TSR is empty, TRMT bit becomes 1, so that it will be able to receive the next data from the TXREG register for next operation. And for the transmission purpose, it is necessary to make SPEN bit high, that is set the, that is transmission is allowed with the help of SPEN is equal to 1. So this is the working structure of USART transmitter. So generally consider that for 8-bit transmission there is no need of TX9 and TX90. So their case is at don't care condition. But for 8-bit or 9-bit, whatever the bits are there for transmission, it is necessary to set the baud rate at the transmitter side. Again, this baud rate is again helpful or useful for the receiver side to receive the data which is to be transmitted from transmitter side. So actual data is received from TXREG register towards TSR, then TSR will shift or move the data towards the buffer, and after buffer it will shift the data towards the transmitter pin, and this cycle continues till the data is receiving from TXREG register. So this is the working of the USART transmitter. Here also mention the USART transmitter, working of an USART transmitter, that is TSR register is an important register, is called as transmit shift register. The shift register obtains data, that is either read write whatever the contents are there, so from TXREG, and for that purpose again for 9-bit transmission TX90 bit is also important, and for setting the baud rate SPBRG is used. So we see next part, that is USART receiver side. As we are discussed about the transmitter side, here we need to discuss about the receiver side. In receiver side, the data is received at RC7 pin, that is RX pin, and after that it will be buffered initially at buffer section, that is buffer and control section, where reception is allowed by making SPEN serial receiver enable. So SPN is equal to 1. After that, that received data is applied to the data recovery section. Data recovery section is useful for deciding the baud rate which is to be transmitted, that is the data rate for which the contents are transmitted. Again here, with the help of SPBRG register, we have to select the same baud rate which is used for the transmission of the data. Here either low baud rate or high baud rate. If it is low baud rate, then it should be divided by 64, and if it is high baud rate, then it should be divided by 16. So based on the status of baud rate selected, so here again data recovery will decides the baud rate and complete rate of received data. According to that, the received data is transmitted towards the receive shift register, that is RSR. So in this register, it contains start bit, stop bit, and 8 data bits or 9 data bits. If it is 8-bit data, it will be directly copied from RSR register towards the RCREG register by removing the start and stop bits. But if the received data is in the form of 9-bit 9-bit data, then the 9th bit, that is MSB bit of RSR register, it will be transmitted or moved towards the logic circuit developed for reception of 9th bit, where the one input of AND gate is RX9, which is already taken care to set to the 1, and whatever the content is received as a MSB bit, that is 9th bit, it will be applied to the second input of AND gate, and it will be reflected in RX90 bit. So for 9th bit of transmission, here it is also necessary to make RX9 is equal to 1, so that we are able to receive 9th data bit in RX9D bit, and remaining the first 8 bits are received at RCREG register and further moved towards the data bus for the next operation. So after reception of the data from RSR to RCRG register, here RCIF interrupt flag is set, and for enabling getting status of RCIF, it is necessary to make RCIE is equal to 1, that is enabling the flag. While reception of data, here continuous reception is also required. If it is required, then CREN should be 1, and next two parts are related to the whether some errors are occurred at the time of reception. These errors are detected like OERR, that is overrun error, and second error is FERR, framing error, as we discussed in registers. So OE error is nothing but overrun error, and in case of overrun error, while first frame of data is received, and before shifting that contents from RSR register to RCREG register, again second data frame is received completely. Like this it will happen. In that case, OERR error will generated, and to avoid this we have to select the actual or baud rate which is selected at the transmitted side. Next error is FERR, that is framing error. Framing error is nothing but while accessing the or receiving the first frame, again next frame will be overlapped with some bits, not completely, and some bits, that is 2 3 whatever, as per the overlapping contents. So this kind of error is called as framing error. So overrun error and framing errors are occurred at the receiver side only. There will be no possibility of occurrence of these two errors at the time of transmitter side. So this is the working of USART receiver. Here mention the working. Some points are there: RC7, that is RX pin, high speed, low speed baud rate selection in data recovery block, which is most important in baud rate side, and see this is the RSR register. So after USART we move towards the next communication protocol used in SPI communication with PIC microcontroller. So SPI stands for Serial Peripheral Interface, and it is commonly used to send the data between controllers to controllers and controller to other devices like memory devices, or controller to sensors, controller to some shift registers, display devices, like that. And here SPI is a synchronous type of communication which needs synchronous clock signal in between transmitter and receiver. In case of SPI and I2C, the words used for transmitter and receiver are master slave mostly. So the master is who which is able to establish a communication between master and slave, that is opponent device, and master is responsible for generation of clock source between master and slave device, and also initiates the communication and completes the communication with the help of slave. So in case of SPI communication, SPI supports for single master multi slave type of communication, that is slaves are more, but mostly only one master is used in case of SPI communication protocol, and it is a full duplex type of communication protocol. Here the basic working model of SPI communication protocol is here it is shown the one master along with some pin connections we discussed, and a number of slaves, that is 1 2 3 4. For each slave there is a necessity of synchronous clock between master and slave. So one pin is SCK, that is synchronous clock, so which is connected in between master and each slave. Second connection is MOSI. MOSI is nothing but master out slave in. Master out slave in. Master out means data is transmitted from master side towards the slave side. Next pin is MISO, means master in slave out, that is data is transmitted from slave side towards the master side. So these are MOSI and MISO are the data exchange pins or connections. After that, for each slave in SPI communication there will be necessity of a SS connection, that is slave select. So for activation of slave 1, it is necessary to send the signal on SS1. For activation of slave 3, master should send the initial signal on SS3 like this. So SS, that is slave select connection, is also required in between master and slave in case of SPI communication. Here, in case of SPI communication, slave is responsible for detection of required slave, that is SS is responsible for detection of required slave. So for connecting number of slaves in case of SPI communication with one master or single master, it is necessary to use the different pins or connection for the each slave. So this is the working of an SPI communication. Here in this block diagram, arrow shows the direction of data from which either it is moving from master to slave or slave to master. So after that, this is the working SDA, that is master out, master in, as SDA pin is mentioned in pin diagram, SDA pin is mentioned in pin diagram of PIC microcontroller. Here SS, that is chip select, which is used to select the chip. Next part or next communication protocol is I2C communication in PIC microcontrollers. The word I2C means inter-integrated circuit, or sometimes it is referred as I2C, IIC, inter-integrated circuit. This is commonly used to send the data between microcontrollers and sensors mostly. And in case of I2C communication protocol, it supports multi-master, multi-slave. This is the most important feature of I2C, that is masters are more and slaves are also more. In case of SPI, only one master is there and slaves are multiple, but in I2C, multi-master communication is also possible in a single circuit. And generally it is used for short distance communication, and it requires only two lines or two wires for the communication. Instead of that, in case of SPI, here in case of SPI, four lines are required minimum, and after that number of slaves are there, then again lines are increased. So in working of an I2C, here first master, slave 1, slave 1, slave 2, like this, and suppose we consider the second master is also there. For this SDA and SCL, SCL is nothing but clock which is connected between master and slave for each and every synchronous type of serial communication. And another line is SDA. SDA is nothing but your serial data, and serial data line is also connected between each master and slave device. For the I2C communication, here two registers need to be connected in between SDA SCL lines with respect to the VDD or supply connections. Mostly these register values is 120 ohms for terminating an additional supply providing. So these registers are also called as line terminating registers. So circuit is more simple in case of I2C as compared to the SPI communication. And here which is I2C is used for long distance communications as compared to the SPI is used in short distance communication. This is the basic working of an I2C. After that, we discuss some points related to that. So here SDA line is used, SDA, SCL, two lines are only used. Next point regarding the I2C is accessing the multiple slaves. Here I2C uses a frame which includes the address of the different slaves. So address is provided with the help of either 7-bit address or 10-bit address. So according to that, the address is specified, and from that master will send that address frame towards the all the slaves, and whose address is detected, according to that reply or acknowledgement signal is given from that slave towards the master, and according to that master will initiate or start the communication between that required slave, and communication will establishes. The second part of this is that In case of I2C communication protocol, we have to access the multi-master multi-slave type of communications, but when first master started communication, we have to wait to establish the communication from second master to other slaves or the same slaves. So after completion of the communication between first master and slave, the second master will be able to start the communication between that particular slave or any other slave. So at the time of simultaneous communication, it is not possible. So after completion of first, we are able to transmit the next or establish the communication between next slave. So we discuss the difference between I2C and SPI communication protocol. So I2C is a multi-master multi-slave communication protocol, whereas SPI is a single master multi-slave communication protocol. I2C generally supports for half duplex type of communication, and SPI supports for full duplex. Here I2C requires less number of connection wires, that is only 2 wires are sufficient, but here SPI requires more than 2 wires, that is data transmission, reception, slave selection, and clock is also there. So minimum 4 wires are there, along with the 5th wire is slave select. So I2C is used for long distance communication, whereas SPI is used for short distance communication. I2C consumes more power while used as a working, and SPI consumes less power. SPI I2C is less susceptible to the noise, that is noise immunity is more in I2C as compared to the SPI communication protocol. And I2C is developed by NXP, and here SPI is developed by Motorola. So these are the some differential points between the I2C and SPI. As compared to the economical constraint, the SPI is more costly as compared to the I2C, as circuit complexity is more in case of SPI as compared to the I2C, but the line terminating registers are required in I2C, but there is no requirement of line terminating resistance in case of SPI communication protocols. So this is the communication protocols used in PIC microcontrollers. As we discussed, USART transmitter and receiver working, after that SPI communication protocol and I2C communication protocol. So thank you for listening and watching. Thank you. Have a good day.